All right, we're going to go ahead and look at number 1. So for number 1, you need to look at the two options here. You have 14 and 19. So what you want to do is, that is not supposed to move. Let's try that again. So you're supposed to take 14 and 19 and subtract them to get 5. And then you also want to take 14 and 19 and add them to get 33. And so x needs to be bigger than 5, but less than 33. And the reason for that is if you put 14 and 19 end to end, and you tried to make a triangle out of it, it just wouldn't work. You need to have this side up here just a little bit less than these guys here together. The reverse is if you took the 19 and then took the 14, so here's 14 and here's 19, this here would be 5, which would make a straight line there. We don't want it to be a straight line, we need it to be a little bit more than that, so I need to be a little bit more than 5 in order for that to work. So, since I am in between those two values, why is that moving? Alright, so if I'm in between those two values, then what I need is 33's out because it can't equal 33, 5's out because it can't equal that, 4 too small, but 27 is a possibility for that third side. All right, let's go ahead and look at number 2. For number 2, these guys are parallel, and we know that because of those little arrows right there and right there. And I also know that I've got all sorts of things that are equal to each other. So let's look at 4 and 7. 4 and 7, this one and this one, we actually know they're not necessarily equal to each other because one is obtuse and one is acute. If I look at 2 and 7, so if I look at 2 and 7, that puts me here and here, and those guys are, I've got my vertical angles here and then my corresponding here, so 2 and 7 is going to be congruent to each other. I also have, let's see, 6 and 7, these guys here are vertical, so those guys are going to be equal to each other. And then I have 4 and 8, which are corresponding, so those guys are going to be equal to each other as well. So I have actually 3 options of angles that will for sure be equal to each other. So let's go ahead and look at number 3. For number 3, I am rotating this clockwise around the origin, so I'm talking about this direction here. So I'm going to take my A. It used to go over 2 and up 1. So now it's going to go down 2 and over 1. So here would be my new A prime. And now we're going to look at C. So C, let's see, we used to go up 3, so we're going to go over 3. And we used to go over 5, so we're going to go down 5. So we're going to down 5 and over 3. Put a little C prime there. And then I do need my last and final one for my B. So I'm going to go, I used to go over 6, up 6. So now I'm going to go down 6 over 6. So I have my B, and so that would be my B prime, and I connect them all to make my rotation. All right, let's go ahead and look at 4 and 5. So for these guys here, we are asking about which angle name justifies this equation, and so the equation is that they're equal to each other, and these guys, hopefully you recognize them as alternate interior angles. And so since they are parallel, that's what they told us up here, then the alternate interior angles are going to be congruent to each other. But again, we got to know that they're parallel. So let's look at 5. 5, you have to set something up. So 3 and 6 are what's given to us. These, again, are alternate interior, and so you should know what to do. And so we set up 3x plus 32 is equal to 4x plus 21. And so then I am going to subtract my 3x, so I'm going to get x. I'm going to subtract 21, I'm going to get 11. So x is equal to 11 degrees. My complete reason is parallel lines imply alternate interior angles that are equal to each other. Thanks for coming.